ALPHA Electro is no different to fly than the gasoline version, with one exception. It has short legs, about an hour or so of endurance, so the Electro is designed to remain in the pattern as a landing trainer. Like the gasoline model, it has a brisk climb rate, easily 1,000 feet per minute initial, and gets to pattern altitude quickly. That's a good thing because during all phases of flight, you really need to keep an eye on the remaining battery capacity, which is easily done via this large power monitor. That vertical bar in the center of the display shows battery remaining, and the round gauge in the upper right shows actual power level selected. On final, with the throttle at zero thrust, the Electro's prop mill will drive the motor and recuperate or regenerate between 2 and 5 kilowatts until power is commanded again to climb or go around. On the day we flew, it was gusty and bumpy, and that requires a little bit more power. I did say that from inside the airplane, the noise level is not that much different than a gasoline model. However, outside the airplane, it's another matter entirely. After our flight, Nate did some low-altitude, high-power passes, and although there's wind noise over the mic, you can sense how quiet the airplane is. Flight schools in Europe, where the Electro is generating a lot of interest, will like that a lot. Charging is done with this purpose-made charger through a plug in the belly of the airplane. It requires between 45 minutes and 2 hours, depending on the battery state. Our flight required about €2 worth of electricity, or about $2.25. Here's Pipistrel's Tina Tomazic.
So the ALPHA Electro here in the background is actually a product that features two major innovations. One is the prop mill, which is a special propeller shape that is able to be effective both in the thrust regime and in the regen mode. But the second, perhaps more important, is how the battery architecture is done. In fact, we have both a quick replace and a quick charge system that is connected to our proprietary BMS. So in the plane there is 6 enclosures which can be pulled in and out like a set of drawers, literally making the aeroplane ready to fly again in a matter of minutes. 2 to 5 minutes is all you need, or they can be recharged in between 45 minutes and 1 hour. The BMS stands for Battery Management System, and it monitors every single cell in the system. So there is upwards of 600 battery cells in the ALPHA Electro, and every 1/10 of a second we know exactly what their voltage is, what the current, and what the temperature. So using this set of data, we do not only provide the pilot with a set of readable and useful information that he can utilize in order to maintain safe flight and also plan the progress of the flight, but we also track the performance of the battery, and we are able to anticipate a battery malfunction. So our BMS technology is not about detecting failure, it's about anticipating, forecasting a failure. So there is 2 levels of protections because in the ALPHA Electro we maintain control over the complete powertrain. There's a set of warnings, of course, like it's normal in aviation. The second layer of protection is actually power derating. So the system would reduce power on the system while keeping the pilot in the loop, actually notifying the pilot about power being lowered. And the third set of reactions is actually associated with the battery disconnect. So a set of contactors would disconnect a portion of the battery or the complete battery, enable to protect it from a complete failure. Professor Gregor Veble, who designed the propeller, calls it a prop mill, reflecting its dual logic or duality of the design. So it behaves like a propeller during its thrust regime. So when you add power, it still provides thrust. But when you are essentially idling down on the approach, it functions exactly as a windmill would, being efficient both on the thrust and the windmilling side. The pilot would not notice any shocks or any change in behavior. He would only notice an increased rate of descent because while the propeller is burning energy, so to say, converting it into battery charge, it is also reducing the overall energy state of the plane, making it sink more.